Right, more live coding. This time it's problem 3 of tutorial 1 called Kaleidoscope. I don't know if you know what a kaleidoscope is, but essentially it's a kid's toy. It has some serious uses, but I think it's more common as a toy. Essentially a tube like this, and in the one end there's a small hole that you can look through. The other end has a rotating part that contains loose crystals, and if you look through the hole you'll see a pattern like this. So as you rotate the front end, the crystals shift around and it forms different beautiful patterns. So I've wanted to play with kaleidoscope images for a while, and this was my opportunity to do that. The question asks, write a program kaleidoscope.java that takes one command line parameter, the name of an image file. Your program must create a kaleidoscope version of the image by mirroring and rotating one section of the image. When it is done, it must display the resulting image, and the tricky part is to find the correct mathematics to map the pixels to the correct position. Yes, we'll spend a little time on that. Given an image, the required transformation works as follows. So here's an image with a lot of A's in it. It says only the yellow part of the original image is retained. So only this part. The other triangles are either a reflection or a rotation of a reflection of the yellow triangle. Yeah, so we can see that. Below it is a reflection of the yellow, drawn in black and white, but still. That A is reflected around this line, so the yellow image is reflected up there, and that is reflected again and reflected, or we can see that this A is rotated up there and again there and there and there, and that's what we'll do. We'll use rotation like that. The first step is to find the mathematics that maps any coordinate inside the triangle to all the coordinates outside the triangle where the pixel must end up. Ooh, this sounds a little too... well, who knows? Note that there are pixels in the four corners that do not receive any value. Yeah, so these pixels are not really going to be anything. As you can see here, down here, they stay black, they are black. In the kaleidoscope image we saw earlier, there aren't these black parts, but in fact they just put another mirror in here that reflects what's inside what is really a hexagon. Actually, the hexagon, you can see the hexagon here. We won't do that, we'll just keep it black. And instead of six-fold symmetry like in this has six-fold symmetry, so essentially 3 mirrors, 4, 5, maybe 5 mirrors. We'll just do 8-fold symmetry. It's a little easier, just a little. So it says, use the picture class to create the image. You may assume that the image is square. That will help a lot. For example, if flower.jpg contains that picture, and your program is called as, well, we're given flower.jpg on the command line, it must display this, which is quite beautiful, but not quite as exciting as I'd hoped. But we can see that this part of the image, so essentially this triangle here that I'm marking, is retained. It's difficult to see with all this reflection, but essentially it stays. Okay, right, let's do this. So I wonder if this is done correctly. It looks more like the bottom part is retained. Who knows? We'll see. We'll see. Cool. Right, so I think I know what I must do, but first, before I write any code, I'm going to think about the mathematics. And I prepared a few slides to talk about that. So this is my image, and these are the triangles I need to reflect. So essentially, if there is something here, and maybe there are other things in the picture as well, but they are going to be lost. Only this triangle with the red dot in it is staying, and it is reflected down around this line up. This will be reflected like that again, and so on all around. So really only this triangle is kept, and it's repeated throughout the image. And the way I'm going to do that, I think, is to start with this triangle, the pink triangle, and reflect it down. So I'm going to walk across this triangle and look at every pixel and calculate its counterpart below this midline. So that's coordinate 0, that's W, the width, so that's half width. So I'm going to start at half the width, and maybe I'll start at 0. I'll call this 0, but its real value is W divided by 2. So I'm going to add that to my x-coordinate. Yes, my x-coordinate is going to start 0, go to W divided by 2, but the real coordinate in the picture will be that x plus half the width. And I'm going to, for each x, I'm going to go up the right amount and get the pixel and put it down here. So this pink triangle will be reflected as a green triangle. And now I've got this, what is that, 1/8 of the picture that I need to rotate. So I'm going to take this yellow triangle, walk across each of its pixels. Once again, x is going to go from 0 to half width, from this bottom to that top, and each of these pixels I'm going to rotate 1, 2, 3, and so on, up to 7 times. So for each of these pixels, I'm going to rotate, put it there, 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 and so on, 7 times. And the rest stays black. Okay, right, let's do this. Let's get cracking. What do I need to do? I'll take these screens away. So I need to create a new package that I'll call, click Kaleidoscope. And inside, I'm going to create a new Java class called Kaleidoscope. Finish. Right. It will have a main, and this main is going to use picture. Pic is a new picture, and we already know that I can give a file name, a string, and it'll open that picture for me. And then I'm going to create the kaleidoscope image, which will be the same size, but I need to remember the sizes. So pic.width, int h is pic.height, that I can do. And I'm going to create the kaleidoscope image, which I'll call cal. It's a new picture. Actually, I can give it the old picture, and then the, well, no, well, let's just make a new picture. Right, so now I've got to copy that first pink triangle to the green triangle. So I'm going to say x goes from 0 to half width. So that is my x coordinate, traveling from 0 to half width, but the real coordinate in the picture is x plus half width, because I'm starting in the middle. So x will be 0, but the coordinate will be 0 plus half width, and that'll give me this pixel. And over here, x is going to be half width, but the coordinate will be half width, w over 2 plus w over 2, which will be w minus 1. Right, okay, fine. I think I've got that. Now, for each of these x's, I want to calculate how high should my y go. Now, that's a simple formula. If this is x, this at this coordinate, and this is y over x is the tangent of this angle, which I know because that's 90 degrees, that's 45, that's 22.5. Okay, so I can calculate the max y. I can calculate that height. And that's not what I wanted to do. Calculate that height. So let's do that. Max y, actually I'll keep it as a double, not as a souffle. Double max height is x times the tangent, math.tan of math.2 radians 22.5. I'm just going to assume that you're very comfortable with this kind of calculation because we did it in the first semester a lot. Right, and now my y coordinate, int y, can start at 0 and it can go until while it's still less than max h, y plus plus. And I'm going to get the pixel at this coordinate, pic.get. Now, usually I'd just say x and y. But of course, remember, x started in the middle. So even though it's 0, its real coordinate is w over 2. And the real coordinate for y is, and I think this is where my example was a mistake in the problem description. I think that should be that. So now I've picked up the color at a particular coordinate here. I've got to put it in the same spot in the kaleidoscope image and also reflect it down. So let's do that. So in my kaleidoscope image, do a set x, y will be c, but once again we have to add plus, and this will be h minus 1, and is this correct? H over 2 minus y. Yes, it's from the middle up. And then the green square, that's the pink, not square, triangle. And the green triangle is the same as the x coordinate is the same, and I'm from the middle down. Oops, down. Right. So I think that will reflect that one triangle. And even though I haven't done the rotation yet, which is my next step, I'm going to show this picture just to see if it's correct. Right. I'm gonna run it once. Java will complain. I always do that. I haven't found a better way of doing it. Run configurations. The arguments should be $string prompt. Apply and just run it immediately. I don't want to kaleidoscope Justin Bieber. I'll use flower, which I copied in a little earlier, right after the previous video, in fact. Okay, right, cool. And I think it is different from the example in the tutorial, but I think this is correct. So let's compare it to the example in the tutorial. So this is a different size because I've enlarged this window, but can I make it smaller? Oh no, wrong way. I think this is correct. Right. So let's just see. Yeah, I think this is right. I think this is correct. Maybe. Well, I know this reflection is correct, and I feel that this is, I should analyze this image, but I think it's more, yeah. Well, if it's not correct, it's very close. And I think that this will be different. Yes, it's definitely different. I can just see this triangle is not the same, doesn't contain the same stuff. Because I think this example is wrong, but we know how to I think I know how to fix it. Let's do it immediately. I think this is the mistake. That in the tutorial picture, they used a plus here. Let's run it again. And let's get this. See, now it's perfectly the same. This, if we could see through this image, we'd see that they're exactly the same. And that's fine. But essentially what they're doing is they're taking the green triangle, which is at the bottom, and reflecting it up. So that's what the example in the tutorial did. It took the green triangle and reflected it up, and that's not technically correct. Well, I wrote that program. I'm talking about them, but it was my mistake. But let's do it the right way. I think it's more fun. If I can only type. There we go. Right. Okay, so first triangle done. Next step is to now go over this yellow triangle and rotate it 7 times. Okay, so I'm going to use the same technique. I'm going to say I'm going to write a comment to myself, reflect the pink triangle down. And now I'm going to say rotate the yellow triangle 7 times. Okay, so once again I'm going to have a for loop with the x coordinate. That goes from 0 to width minus divided by 2. So x will move like that. And once again I'm going to calculate the max h. But this time I'm not going to iterate y from 0 to max h, but from minus max h to plus max h. So I'm going to, x is going to move from there to there, and for each x, y is going to move from down here, minus max h, to there, max h. And max h, once again, is calculated with the tan, and it'll be the height at this point, at this x coordinate. Right. So, I'm going to copy this formula down. I'm even going to copy this for loop. I'm going to take it down. Right. But this time it doesn't start at 0, it starts at minus max h. I can't start at minus max h because it's not an integer, but I can force it to be an integer by putting a cast in front of it. Good? I hope that's right. Well, if it's wrong, it's just a little wrong. It's probably not a lot wrong. Yeah, cool. Right, and now now I'm going to calculate the rotation. So how do we rotate a point through how many degrees? From here, I want to rotate to there. That's 45 degrees. So if I've got an XY here, how do I find its rotated point? Well, the answer is you Google, and there are formulas. Let's just go forward. On the internet, they tell me exactly how to do that. So here is the formula. If I'm at position old X, old Y, and I want to rotate that point through an angle, my new X and new Y is given by these two formulas. They look a little complicated, but they're not that bad. And it's not something I remember. I Google for it all the time as well. So I'm going to keep this off screen, but I'm going to retype it soon enough. So I'm going to keep old x and old y in a variable, and you'll see why shortly. Old y is y. Okay, they're in variables. And now I'm going to rotate 7 times. I'm just going to call it r is 0, r less than 7, r plus plus. Well, maybe the first step will be to read the color at the point x, y. So I'm going to copy that down here. There we go. I've got the color. I store x and y in old x and old y. I'm going to calculate new x and new y. New x is old x times the sine of math.2 radians of 45 minus old I times math.cosine. Why does Eclipse pick the wrong function all the time? Okay, right. So we can see what's going to happen here. This line is just too long and too ugly. Plus, this is a constant value. It never changes. In fact, this is also a constant value. It never changes. I mean, it doesn't matter what x and y is, or this is a value that stays the same throughout the program. So I'm going to use my new knowledge of static final to make a constant. Double the tan of 22. I'll just call it that. And that is equal to this value. Copy and put it up here. And now, instead of calculating this every single time and looking pretty ugly, I'm going to write tan of 22. And then I'm going to do the same for the sine of 45. Sine of 45, and for the cosine of 45. Cosine of 45 is math.cos. Okay, so I'm declaring 3 fields. They're class fields, so they're shared by but that's not so important. The fact is that they're final, and that means they're constants, which is why I'm using uppercase. So everywhere where I used tan 22, or the long formula, I can put tan 22, and where I use this, I can put sin 48, and also cos 45. Okay, and new y is and that's sine, I think. Right. Now, Eclipse is complaining because this is a double value and I'm trying to assign it to an int. I'm just going to cast. And Eclipse offers a useful quick fix. So I'm just going to select do what Eclipse says or suggests. And that's fixed that. And I'm going to put this in the new spot. So in the Kaleidoscope image, set new x, new y to C. Except I have to remember that I have to add this value because my coordinates x, y, old y, new x, new y, they're all in terms of the middle of the picture being 0. And here I've got to put it in front. H over 2 minus y. There we go. Right. So let's just recap. X goes from 0 to half width. I calculate the max height of the triangle at a particular x. Then y goes from minus that value, so below in the green triangle, to max h, to the top of the pink triangle. And I pick up the color in that triangle. And then I set old x and old y. And 7 times I calculate a new position, rotate it. But I've done a little mistake here because nowhere in this loop do I use R. I've got to make sure that I'm not making a mistake. Every time this loop executes, it'll just take the X and Y coordinates, rotate it once, put that in new X and new Y, and set the pixel in the image. So effectively what I'm doing is 7 times I am taking old X, old Y, rotating it, and setting new X, new Y. Take old X, old Y, and set new X, new Y. 7 times. What should happen is that once I've set this pixel, it becomes the old X and old Y. And it is rotated and set, rotated and set, rotated and set. So what is missing from my for loop is that at the end, after I've set the pixel in the new triangle, I should say old X now becomes new X. And old Y now becomes new Y. And I think that this is it. I think that this is all we need. I start by reflecting the pink triangle down. We've talked about how to do that. And here I am taking the yellow triangle and reflecting it 7 times. Okay, let's see if I'm correct. Does this work? Kind of. No, I want this window. So firstly, this is different from this because I've actually used the correct way to calculate reflection. But definitely this is a pretty ugly picture. I mean, look at all these patterns here. And the reason for that, these stripes and dots, is that a reflection or the conversion from doubles to ints is not perfect. So when I cast that formula, let's close that. Well, no, let's keep that. When I cast this formula to an int, I'm losing precision. And there's not really a nice way to fix that. But you can fix it. I mean, what we can do is to say, I'm not going to walk in 1 pixel, I'm going to walk in half pixels. So instead of pretending I'm going from 0 to width over 2, I'm in fact going to say this region here is 0 to width. So my coordinates where this is 0, 0 will go from 0 to width and from 0 to height. And then only when I do the set and the get will I convert back to the original coordinates. So let's do that. So here I'm not going to go to width over 2 but to the whole width. Max h can stay the same. I'm still going from minus max h to plus max h. But here where I convert x and y to the real coordinates, I should compensate for the fact that x goes all the way up to w, not w over 2. So this x should be divided by 2. This y should be divided by 2. Old x, old y can stay. I'm still reflecting 7 times. This conversion can stay as it is, I think. But here, once again, I should be dividing by 2, dividing by 2. Now this is the tricky part to understand, and if you don't follow it perfectly, ask questions in class and look at the video again. But let's see if this did the trick. I think it'll work. It almost worked. It's almost perfect, but not perfectly perfect. Let's see if we can fix that. How would we fix that? Well, one way is to say, I can even go to 2 times w and then divide by 4. In fact, let's do that quickly just because it's so easy. I'm going to walk up to 2 times, but here when I convert back, I'm going to divide by 4. That should be divided by 4 divide new y by 4. Nothing else needs to change. And this will do something. And it does work. Although I've made a big mistake. Oh no. Okay. We all make mistakes, and I made a big mistake that I only see now. So it looks quite beautiful, but now that I look at it, this triangle is not rotated and placed here. I mean, there's a dot there that is not in the original, and I know why this happened. It's because to rotate this triangle to there, I should be picking up the pixels in the kaleidoscope image. This triangle is not the same as the original. Let's get the original on screen. This is the original. So I took this part, so this part of the image, and I reflected it down, and that worked perfectly. But then when I work with this triangle, I wanted to rotate it, but instead of rotating this triangle, I was rotating this triangle, which is why this dot, this bud, is now in all the reflections. So this is easy to fix. I know exactly where my mistake is. It's right here. When I'm rotating the yellow triangle, I should pick up the color from the kaleidoscope image, which now has the green and pink in that position. It's the green and pink triangle that forms the yellow triangle that I want to rotate. Okay. Let's try again. If we don't see the bud, then we know it worked. Yes, there we go. There we go. This is perfect. This is what it's supposed to be, but we can duplicate the mistake in the Tut question by putting this back to a plus again. I just want to make a comment to myself that this is the correct way of doing it. Correct way, and this is the Tut way. We'll call it Tut way. So by only changing this one plus, I am in fact changing. Well, it's a small change, but you'll see now. So there we go. That's a perfect match. That's a perfect match. Okay, so let me explain what that one change does. That one little change from a plus to a minus is the difference between reflecting pink to green, which is what we should do, or reflecting green to pink, which is what the Tut did. So if you go h divided by 2 minus, plus y, and you put it there, then you're putting green into pink. But if you go h over 2 minus y, and you put it there, you're reflecting pink to green. I hope that's clear. Okay, one last thing, and that is that I want to see my own image, which I've got here in a picture. I just want to see what I look like when I'm kaleidoscoped. There we go. I look like a pie. That's amazing. Oh, I like that a lot. What is that line? What is that? So let me just do this. It's my glasses. It's the bottom of my glasses just being picked up. Is it? No, I'm not sure. Okay, I'm gonna stop. It's too much fun. Okay, excellent guys. That's this problem done. And now we're done with the whole of the first Tut, and I'll put up more videos for the second Tut and the third Tut as well.